minute to get to have people sign on. Just one more. Good morning, everyone. Welcome back. If you are coming back from last week's session, we are here again today for our second webinar of the 6-part webinar series of the Construction Workforce Training. Today's class is the Pathways of Compliance in the Structure of the Residential IECC. I'd like to thank our community partners, Xcel Energy and the City of Fort Collins, for making this possible, and of course, BUILDTank with Robby Schwarz. We've all come together to make this possible for you for the next, or for a total of 6 weeks. If you are not signed up for the upcoming classes, make sure you visit our website at nocohba.com under professional development. You will see the list of upcoming classes. And then if you weren't able to make last week's class, we do have that available for you to view on our website. So let's go ahead and get started. Robby Schwarz, I would like to introduce him. He is the owner and founder of BUILDTank, and he has been the champion of the applied building science industry for over 25 years. So I'd like Robby to go ahead and get started and take it away.
Great, thank you very much, Nikki, and thank you again to the sponsors of this training series. It's greatly appreciated. I'd also like to announce that we now have the ability to offer CEU credits for both IECC or ICC credits and AIA credits there. So let us know if you need those credits as well. I'm going to take myself off of video now and move forward through our presentation. And if you have any questions, please don't hesitate to write those questions into the question box, and we will look at questions at the end of the presentation here. Today's plan is to look at the residential section of the IECC, go through how it's set up, spend most of our time with regards to the pathways through the code, the 4 main pathways, or really the only pathways through the code, but there are 4 of them, and they're complex, and some are more flexible than the others. So as we know, and we talked a little bit about last time, we have a lot of expectations of our homes. We have expectations of shelter. We have expectations that our homes will be comfortable, that our homes will be durable and last for years and years and years, that our houses will be aesthetically beautiful, that they'll be healthy and sound and safe, and that they'll be energy efficient. These expectations are, as we talked about last time, are really driving the building science and helping us build houses that can meet these expectations. However, there is a disconnect between the home buyers and the building industry. The home buyers are really, this is the largest purchase that they'll ever make in their life. And the reality is that they have the least amount of knowledge about the products that they're buying. So the ultimate reality is that they're relying on the integrity of our industry to provide them with houses that will meet their core expectations and that will be sound investments for them. The other thing with this, with regards to code, is that when we adopt codes, we have the ability to amend the code. We can change the code. And so this integrity question is, how do we adopt a code that that will help us meet the expectations that people have of their houses without, in essence, bastardizing the code and making it work. And we begin to see that because there's the introduction of the 2012 IECC really got people's attention. This is the first code that people started really questioning what direction the code is going and how it's ultimately achieving its goals here. There was this kind of apocalyptic feeling about the code. So let's look at the cycles of the code real quick and have an understanding of what's happened with the codes over time. The first thing to understand is that the 2006 IECC is a reference point. It is the reference point that all codes are being compared to, and things like the ResNet HERS Energy Rating Index is being referenced off of the 2006 IECC as well. Now, in relationship to the 2006 IECC, the 2009, there was about a 15% increase in efficiency between those two codes. It didn't get people's attention that much because the way that they achieved that increase in efficiency was primarily increasing R values and U values around the building thermal envelope. Now, between the 2009 and the 2012 IECC, there was another 15% increase in efficiency, and that was achieved by requiring that the house be significantly tighter than it was in the 2009 IECC. So we moved from about 7 air changes per hour to 3 air changes per hour in our climate zones here along the Front Range of Colorado. Now that became a mandatory requirement to do testing, and that really got people's attention because people didn't understand how easy it would be or wouldn't be to achieve that level of house tightness, because there wasn't a significant amount of testing happening before that time period. At least that was the thought process on a national level. Now, from the 2012 to the 2015 IECC, things didn't change much at all. And primarily because people felt that we needed another code cycle to get used to this idea of mandatory testing of our homes. And that carried on again into the 2018 IECC. So what we see with regards to the 2012, 15, and 18 is that the more recent versions are just better written versions of the 2012 IECC. There wasn't much changed, especially in the performance paths of the code. What we do understand right now is that the 2021 code is expected to be another 10 or so % increase in efficiency. So there are some significant changes in the 2021 code. It's still going through the process of formal adoption and correlation at the IECC, and we expect it to be published before the year is out. So it'll be interesting to dive in there and really understand the changes and how it might impact the way that we're building. However, you know, jurisdictions will have to adopt that code and potentially amend it. And my guess is that a lot of jurisdictions will skip over the 2021 and wait to the 2024 so that they can get a better idea of what's there and what the potential consequences of moving to that code will be. So that I think that will happen to a lot of jurisdictions, although there are some jurisdictions in Colorado that have made a point of changing each cycle. So we'll have a good idea of what's happening here soon as we move towards the end of the year. Okay, so let's move into the look and layout of the IECC. So the IECC covers both commercial and residential sections, and there's 6 chapters in each of these sections of the code. We're going to highlight the residential section here. And the other thing to know is that the IECC the residential section of the IECC is Chapter 11 of the IRC. They are the same for the most part. There are occasionally there are some differences, but in general they mirror each other directly here. The residential sections of the code are needing to be enforced whenever residential sections of buildings are being built. So sometimes you will have some mixed-use buildings that will be partially commercial code, partially residential code. So for example, this building has commercial on the first floor, but residential on the 2 floors above, potentially 3 stories above. Therefore, the residential section is working off of the residential section of the code, and the commercial section on the first floor is working off of the commercial section of the code here. Okay. And who's actually using the code? What we're seeing right now is that there are a number of people in the industry who are proactively looking at the code and trying to get additional benefit out of the code. These can be proactive designers or market-conscious builders, building owners who really care about operational costs of their building, and code officials who are aware that the building owners have these expectations of the house and they really want to meet those expectations of the house. So To some extent, the IECC can be thought of as another building program like Energy Star or something like that, in the sense that there are people that are using the code to benefit the ultimate owners of homes and to get the most efficiency that they can and comfort they can out of those homes. We also know that home buyers have these expectations from a code perspective of their houses. They want to ensure that their houses will be durable, that they'll get hot water when they need hot water, and that their utility expenses will be reasonable, that the cost of ownership will be reasonable at the time that they move into this house. And that's really a large part of what this particular code is about, is to ensure that the cost of ownership from a utility perspective, from a comfort perspective, from an efficiency perspective, is going to be created and maintained in that particular house there. When we move into chapter 1, we see that this is the administrative chapter of the code. This is where the code officials often have a lot of leeway in adopting or amending the code, but the code officials and jurisdictions that are amending the code really need to think hard when they look at this chapter and realize that there's some pretty significant things in this chapter that shouldn't be amended out here. So we're going to be talking really about the unamended version of the code, and you need to remember to look at your specific jurisdiction and see how the code might have been amended and adopted at that point there. There is a scope document in the IECC. This one is taken out of the 2012, but it hasn't really changed throughout to the 2018 version here. It says, starting with the 2012, in addition to the code applying to residential buildings, it also is looking at building site and associated systems and equipment that might be on that site. So for example, pool heaters might be, if we had a big market for pools, that might be governed by the code here. So other things that are on the site that aren't necessarily associated directly with the house. The intent of the code is really an interesting part of the code and something that we're going to spend a little bit of time on. The intent statement of the code is one section of the code, but it can be broken into 3 main statements here. The first one says that this code shall regulate the design and construction of building for the effective use and conservation of energy over the useful life of the building. So the reality is that it's talking about long-term durability of a house. How long should a house last? So if we think back to our session last time, we saw houses that were built in the early 1900s and houses that were built today. And our question might be, how long should houses last? Often I get to that answer to that it should be a 100-year-old house. Some people, however, just are concerned about turning over the house and getting it through its warranty period there. But the reality is that the code is looking for long-term durability, whether that's a 100-year-old house or a 50-year-old house, that could be questioned, but the things that we put on the house need to last for the useful life of the building structure there. So we're talking about long-term durability. The second part of the intent statement says that this code is intended to provide flexibility to permit innovative approaches and techniques to achieve this objective. So this is talking about finding the flexibility in the code. And how do we find flexibility in the code? We really need to spend time with the code book and understand the code book and kind of learn from this statement from the Dalai Lama. The Dalai Lama says that we need to learn the rules so that we know how to break them properly. So if we learn the rules and figure out the flexibility in the code, we see that the code isn't limiting us from doing what we've done in the past or from being innovative in the future here. And really, what it's basically saying is that if we don't like what the code is telling us to do prescriptively, then we need to move to a different pathway of compliance so that we gain and learn the flexibility that is built into the code and that we can do the things that we want to do and achieve the houses that will be code compliant, be efficient, be comfortable, be durable for the occupants of that house. So I really urge you to spend some time with the code book, or with some third-party code consultants that can help you find that flexibility and use the trade-offs that are in the code that I'll be showing you later on here to be able to build the houses that you want to build and also create them efficiently. The last statement of the intent statement says that the code is not intended to abridge safety, health, or environmental requirements contained in other applicable codes or ordinances. So the reality of this intent statement is that this code, just like any other code, is a health and safety code. This code might be dealing with carbon monoxide poisoning or having a sound building envelope that can protect us from the exterior environment, from heat exhaustion when it's super hot outside, or being cold when it's really cold outside. But regardless of that, this code is intended to be a health and safety code, just like all the other codes, and should be enforced like any other code from its health and safety perspective here. Now, there's an organization locally called SWEEP, the Southwest Energy Efficiency Project, that did a really interesting paper that talked about all the health and safety aspects of the energy codes. And I urge you to potentially go look at that paper and understand how health and safety correlates with energy efficiency as well here. We just don't have time to delve into that question right now. Now, Chapter 1 also gives the code official a lot of leeway to accept things that they might not normally accept. So there is this provision that says that the code official shall be permitted to approve an alternative material, design, or method of construction. Now, this comes up when we're talking about attached housing often with attached party walls, especially because we like to use these shaft liner walls in townhouses and duplexes. And we have this kind of dueling fire aspect and energy efficiency aspect here. And we know that we have to air seal these assemblies, and sometimes code officials are reluctant if we're not going to use true fire rated materials in that assembly, but they can potentially approve an alternative material like this air sealing foam in this assembly. And so you know there are fire rated air foam air sealing materials out there as well to be used there as well. Another example of that comes with regards to vapor retarders. There are a number of choices of vapor retarders, and some jurisdictions have completely amended out the requirement for a vapor retarder, especially a class 1 vapor retarder in our climate zones, and other jurisdictions are kind of defaulting to it. So if, from a building science perspective, we want assemblies that have the ability to dry. So class 1 vapor retarder, we might not want to put into our assembly. So you can go into the jurisdiction and show them alternate materials and methods of construction that can deal with moisture, that without having the potential of trapping that moisture with the class 1 vapor retarder here. And this section of the code is where you would look for guidance on how to do that. Construction documents need to be turned in, and this section of the code in Chapter 1 talks about that. So each time you pull a permit, you have to provide construction documents, and these construction documents need to be provided and created by a design professional. However, there are these things called compliance documents, and compliance documents are different from construction documents in that they are demonstrating compliance. So the best example and easiest one for people to understand is the report for the UA alternative path that's developed by the ResCheck software, the UA compliance report. That would be an example of a compliance report. And it turns out that a lot of registered design professionals don't want to create that design document. So we're seeing a lot of third parties create these design compliance documents, or these documents that are needed for permitting and also for certificates of occupancy. Now, The other thing that this section talks about is what needs to be included in these construction documents. And on the right-hand side, you see these details, including insulation, windows, mechanical systems, duct sealing. Well, in I believe the 2012 IECC and continuing on to the 18, these air sealing details were added to the details that needed to be included in the construction documents. Air sealing details arise from table R401.2.2.2, I believe, something like that. Anyways, the air sealing and insulation table in the code. And this table says, in essence, that we need air sealing details where the continuity of our air barrier is broken. So for example, the interior air barrier behind a tub, it's pointing out that we need to add a supplemental air barrier there behind the tub. Or in a drop ceiling, get an air barrier up to the attic insulation and to that exterior wall before we build the drop ceiling for this can light over a kitchen cabinet, for example. These types of details need to be included in our construction drawings, and also a section that was added in the 2015 IECC says the building thermal envelope shall be represented on the construction documents. This is just an example of how it's done. In essence, this section is pulling from a building science technique called the red line test, where in essence you're putting a red pen on your construction drawing and trying to demonstrate the continuity of your air barrier and thermal barrier and control layers of your house, so that you can demonstrate that in a conceptual way for the people who are actually building the house out in the field. So that as a designer, what you're designing can better be translated out into the field and actually constructed here. What we see is that that's done in a lot of different ways in our construction documents now. We're seeing full energy pages being added to our construction documents that have depictions of our thermal envelope, that have air sealing details and insulation details and other details on it. So here's an example of a depiction of the thermal envelope on a construction documents. Some air sealing details. People are using these posters that were put out by the Department of Energy or creating their own details. This detail, for example, for the window headers, show how to put foam board into a 3-ply header instead of using spacers of OSB sheathing, for example. Great detail to add to your construction documents. Some way of showing all the R values and U values and mechanical equipment that's going to be used in that particular design and build need to be included. And then this particular architect added some additional things, some of the mandatory requirements of the IECC that the builder might not always be aware of. For example, are you aware that 2 or 3 stud corners and insulated corners and insulated headers are a mandatory requirement of the code? Well, this particular architect felt that they needed to add that detail onto their construction set so that they translated that information over to the builder. Chapter 1 also talks about inspections that have to happen. That was new in the 2015 IECC. So we're talking about footing and foundation and framing inspections, plumbing inspections, mechanical inspections, final inspections, and it even talks about re-inspection here. Now, to look at that a little bit more closely, for framing, it says that we have to verify the R values and their correct location and proper installation, the proper installation of air leakage control required by the code, all those things. On the mechanical side, again, we have to look and verify the required controls and system insulation and corresponding R values. So the R value that's on ductwork, for example, system air leakage, so the duct leakage testing potentially, and whole house mechanical ventilation, which is now a requirement. So this notion of inspecting our houses has really looked and changed from this notion of just looking at, is something there, to saying, has it been installed to perform? And performance codes is really where things are moving here. So when we're looking at inspecting, again, we're not just looking at, is it there? Is this fan in this bathroom to take moisture up and out of the bathroom as soon as it's created? We're also looking at, is this bath fan and ductwork been installed so it will actually work, or has it been tied in a knot so that the air can't get out of that bathroom to the outside? And does it need to be reinstalled there? Here's another example. You know, I can't walk into a house and just look for pink fiberglass in the walls and walk out. I have to look at how it's been installed, and has it been installed so it will actually function in that house, or are our building cavities being used in essence as a trash can here? From an HVAC perspective, you know, did they do the plans for the HVAC design work? Yeah, that's part of the equation there, but has it been installed according to the plan? Is there enough return air? Is air able to be supplied properly to each location there? Those are the things that we're looking for. And the reality is that the City of Fort Collins has really helped us understand this question of, is it there and does it work as it's been installed? So that's really changed the way that we're inspecting for compliance now. The code official is authorized to accept reports from a third-party agency. And so you're going to see that more and more third parties are being used to help jurisdictions inspect houses and ensure that they're complying with the IECC out there. So that can be anything from an energy rater to a code compliance company like Colorado Code Consultants, Safe Build, or Mozingo Code Group would be examples. So there are a variety of different groups out there. Now, if there are any jurisdictions on the phone or on the presentation today as well, you should make sure that you think about having a scope of work document for those third-party agencies so that it's crystal clear that your expectations and understanding of what that agency is looking at is the same that that agency has out there as well. And we can talk more about that at another time, but it's an important thing to think about. Okay, moving on to chapter 2. We're talking about the definitions in the code. There are a lot of things that are defined in the code, including the thermal envelope and air barriers. ERI, what is a reference design for the energy rating index, is defined. Some words are defined in the ICC, and some are defined in other codes in the IEC. So, for example, joint is defined in another code here. Anything that's a defined term, I believe, is italicized in the code. So you can go to the definition section to figure out what exactly they're talking about if you don't know here. Chapter 3 is looking at climate zones and design conditions and some other general information. For example, the interior design conditions shall be a maximum of 72 degrees for heating and a minimum of 75 degrees for cooling. So when we're doing an HVAC design, we have to establish the interior design condition and the exterior design condition, and the interior part of that equation is defined in the code in chapter 3 here. Chapter 3 says that the building thermal envelope shall provide, that the installer of the insulation shall provide a certificate listing the type, manufacturer, and R value of the insulation that is being installed, and that the installation needs to follow the minimum requirements of the manufacturer as well as the requirements that are listed in this code here. It relies largely on the manufactured instructions for installation, but there are specific sections in the code that describe how insulation should be installed as well, and those things need to be followed as well here. So this is an example of the climate zone map that is included in chapter 3. The climate zone map gives us a little bit direction of how to install things and what needs to be installed from an R value perspective in each climate zone here. It is a heating dominated climate zone map in the sense that it makes as much sense to insulate our buildings for cooling as it does for heating, but the code requires more R value for heating than it does for cooling climate zones there. And you can find that in the prescriptive table that's associated with the climate zone map. The other interesting thing about the climate zone map is the moisture section. So you look at the top of the climate zone map, you have the dry B and the moist A climate zone, and that bold black line that divides the country between the moist areas and the dry areas, and then the marine climate zones there as well. And you need to be aware of that because there are different requirements in climate zone 5, for example, for the moist areas of climate zone 5 and the dry areas of climate zone 5. Now, with regards to the R value of insulation that needs to be certified, in essence, this is why that requirement is in Chapter 3. We have a number of materials that are installed in our houses that we have no idea what the R value is unless the installer actually certifies that R value and leaves some type of document behind. In the 2021 IECC, this becomes a little bit more straightforward. There is a specific requirement now in the 2021 that the installer leave a certificate after installation certifying the R value of the material that they've installed when it is not specifically labeled by the manufacturer there. Another example of that would be for attic insulation. We look at two materials here. One R38 is 14.5 inches thick. Another R38 is 10.5 inches thick. I've seen R38 insulation in attics that needed to be almost 20 inches thick or more in order to achieve an R38. So we don't know that. We can't just look at an attic insulation blow and say, oh, that's an R38, if there isn't documentation that's left behind. So it's very important for builders and code officials to begin to require that documentation being left behind. The pictures on the right are examples of how the R value can be certified with installation. These are manufactured devices on the top two pictures that measure the R value of the installation. And then the old technique of cutting out a square foot of area of material and weighing it is the lower picture here in order to get the R value of the material here. But again, the importance of certifying the material that's being installed becomes really important when we're thinking about the link between HVAC design and R values and so forth and so on. Okay, so that certificate, again, shall be posted. So this section, we're jumping into Chapter 4 here because there's another certificate that's required in Chapter 4. This certificate also labels out the R values and U values, but it also is looking for the types of equipment, mechanical equipment in the house, and this certificate looks like this. It reports the R values, it reports the window U values, it reports the mechanical equipment, and it reports the results of the test. So this is a certificate that is posted at the end of construction and is generally created by third parties if you're doing performance testing and performance compliance on your houses, or potentially the builder can create a certificate that looks like this as well. But it's supposed to be left as a permanent document with that house in a predominant location in the house. Chapter 4, this is where we're going to spend most of our time today, looking at the different compliance paths in the code here. So the main compliance paths in the code are the prescriptive path, the UA trade-off path, the simulated performance path, and the energy rating index pathway. What we're looking for when we're choosing a pathway is what is the most cost-effective way to achieve code compliance? Where do we get the best value from the cost of construction perspective, from a payback perspective? We can look at it from a simple payback perspective or the investment that we're making in our loan. So we see that there's a little bit difference between what the builder might think is value and what the consumer might think is value if we look at cost of ownership, for example. But we want to look at which pathway helps us determine the most cost-effective pathway there. And this cost is a little bit different, again, from a builder's perspective, from a buyer's perspective. From a builder's perspective, we're looking primarily at first cost. From a buyer's perspective, we might be looking at opportunity cost. I have only one opportunity to get that insulation behind the drywall and get the most there I can, and at the most, that will impact that cost of ownership the most as well. We might look from a builder's perspective how we are going to leverage the marketing of what we're doing in our house, how we're going to differentiate ourselves in the market. And so that's a big thing to look at here, and how we're going to be adding value to the proposition so that we can differentiate ourselves. Added value is important to the buyer as well, but we also are thinking about how these expectations are met and how we're going to get better satisfaction in our house. How am I going to achieve comfort from room to room and floor to floor? The builder might be thinking about less warranty, so they're adopting these building science practices and what the code is trying to help them do. So ultimately, we're thinking about how to choose the right pathway that will meet these value propositions for these different constituencies here. These pathways ultimately provide flexibility in the code as we move through them. And we'll have a pretty good idea, I think, which is the most flexible by the time we're done here. So regardless of the pathway that we choose in the code, we have to remember that there are mandatory requirements. And the mandatory requirements need to be met regardless of the pathway that is chosen in the code. So remember, we said that there's a prescriptive pathway, there's a UA compliance pathway, there's the simulated performance pathway, and there's the energy rating index pathway that was the most recently added pathway in the code of compliance. That was added in the 2015 IECC. And so we're on the same page. Let's make sure we defined mandatory and some other things in the code. So first, mandatory requirements are requirements that must be met by every building unless there is a specific exception in the code there. We have these prescriptive requirements, and these are requirements that must be met by every building unless an approved trade-off is utilized or unless there is a specific exception in the code. So when we talk about trade-offs, we're talking about trading off R values and U values. And that is done through this performance approach, which is an overall performance requirement for the building that replaces the individual prescriptive requirement for the building systems or components. And the performance requirement is able to trade off R values and U values in our assemblies here. So what we see is that the mandatory, everything in the code is mandatory unless there is a specific exception in that code. Everything in the prescriptive section is mandatory unless you can do a trade-off or there is a specific exception in the code. So for example, attic eave baffles are in that prescriptive section of the code. They aren't labeled as mandatory, but they are mandatory because there isn't an exception not to install them in a ventilated attic, and there isn't an ability to trade off that because they aren't dealing with R value or U value. Some of that would be true with crawl space vapor retarders as well. And then there's some more confusing ones in the code for floor insulation and attic insulation, for example. There's sections in the code that talk about how you install that material. So the installation requirements are mandatory, but the R value requirements are not mandatory. Those are things that could be traded off. So we need to look at that prescriptive section of the code and understand what's mandatory in that section and what isn't mandatory in that section. And generally speaking, those things that are talking about how you install something, those are mandatory. Those things that are talking about R value in the prescriptive section, those are not mandatory. Those are things that can be traded off. So the prescriptive section overall is our most restrictive pathway. So if you're looking for flexibility, you're going to immediately move beyond the prescriptive pathway in the code. There's no computer compliance tool. It's basically thou shalt do what is listed in that table. And I'll show you the table here. You've got to declare that you're using the method of compliance, and your permit plan needs to document that as well. The prescriptive section says that that the building thermal envelope shall meet the requirements that are in the R value table or the U value table. Those are those two sections there. And that the R value table needs to be used in that section, and that you compute the R values shall not include the R value of other building materials. So in essence, what it's saying is that the R values that are listed in the R value table of the prescriptive code are the R values that need to be installed in the cavity that you're insulating. So in the wall cavity, the floor cavity, the attic, the rim joist, all those locations that are given an R value is talking about the specific R value of the material that's being installed. This section, however, also deals with the U value table, the prescriptive section of the code. The U value table, however, is used to begin the process of doing trade-offs. So I'm going to break it out separately here as a different compliance pathway here. And that gets us to the total UA alternative approach here. So before we go there, let's look at the R value table. The R value table had, in our climate zone, climate zone 5, it tells you what R values and U values you have to put in specific sections of your home. This is mandatory. You can add more than, but you can't trade off and add less than. So for our attics, it says that we have to install R49 in our attic. I can install R100 in my attic if I want to, but I cannot install R38 if I choose this pathway. I have to install 49 or better. There are a lot of footnotes in this table as well, and so you need to learn the code so you can break the rules properly, like the Dalai Lama said in the intent statement. So you need to look at this table, but also read the footnotes in this table so you know how to look at that. So, but again, this table is only looking at the cavity R value of the components that are listed here. How you implement this table is interesting. So from a best practice perspective, for floor systems, for example, is to insulate that cavity completely full of insulation. However, the code says that you only need an R30 in our climate zone in a floor system. However, we're looking at how things are performing and installed now. So we often use a stay wire to hold the insulation permanently against the subfloor. And that's what the section of the code says, that you have to install the insulation so it maintains permanent contact with the underside of the subfloor decking. If that stay wire is overly compressing the insulation, we no longer have an R30. Therefore, it's not a code compliant installation, and it needs to be reinstalled so that we have the full depth of that material and we have the full R value of that material being installed here. So it's an interesting thing to think about, that we're not only looking at, is the insulation and R value there, but has it been installed so it actually works and perform. Another example of this is how we used to install insulation. We used to install insulation so it wasn't in contact with the subfloor, but potentially ducts could be installed in that cavity. We know that our insulation, that our ducts in floor systems don't work very well. So the code requirement is that insulation is complete contact with the subfloor, that insulation completely encapsulates or encloses any obstruction in that cavity. And footnote G in the insulation table says that we have to have a minimum of an R9 below a duct. So how do we do that? We fur down the cavity around that duct, and we potentially blow insulation so it's in permanent contact with the subfloor. It completely surrounds that duct, and we get a minimum of an R19 below that duct. So it actually works here. Now, the U-factor alternative table, this is a table that is largely being produced because we need U values in order to do any computer modeling of a home. So this U value is not just the cavity R value, it's also the assembly. It's looking at the total assembly R value for each of the components that are listed here. So to just take that as an example on how they correlate between the U value table and the R value table that we looked at before, we are looking at the wall R value in climate zone 5, and we see that the U value is 0.06 and the corresponding R value for the whole assembly is almost R17 here. If we take the reciprocal of the R20 that's in the R value table, we see that becomes a 0.05. If I added the sheathing and the air film and the drywall and the studs and all the other things, I'd get closer to that 0.06. So the reality is that what the assembly R value and the cavity R value, they're trying to do exactly the same thing, and that's what I'm trying to demonstrate here, that they mean the same thing. They're just been created for different purposes. The R value table is for that prescriptive R value that needs to go in the cavity. The U value is really giving us the ability to use computer software modeling here. And the 3 compliance pathways that use computer modeling is the UA compliance pathway that's in that prescriptive section of the code, section R405, which is the simulated performance path, and section R406, which is the energy rating index pathway here. These softwares are trying to do something pretty simple here. They're trying to define the delta T, or the temperature difference from inside to outside of our houses. The software describes these thermal components of our homes and give a delta T location between inside and outside of our houses of every component that's built into that software there. And this ultimately describes the heat loss of our buildings. And as we learned last time, that heat loss is always from warm to cold here. So when we build a house inside of our software, we do a takeoff and we build all the components into the house, and the software builds a reference home. The reference home is a home that the rated home that is compared to. The house that we're actually concerned about, we call the rated home, and that rated home is compared to a reference home. Now, the reference home is defined as a standard set of house specifications that generate a specific, consistent, and quantifiable energy performance. So the reference home is built off of the code, actually the prescriptive section of the code. Those prescriptive R values and U values are overlaid onto the reference home components, and the rated home components are compared to that there. So like in the picture, I have a rated home and a reference home that are geometric twins of each other. Now, there are different types of reference homes out there. There's the IECC reference home. There's a HERS, or a home energy rating system, energy rating index reference home. Energy Star has their own reference home, and a lot of utilities use their own reference home as well for utility rebate programs. Now, the reference home versus the builder's house for the simulated performance, for the UA trade-off pathway. Again, they're geometric twins of each other. Once we've built this house inside of the software creates a second house that's called the reference home. They're geometric twins of each other. The reference home is overlaid with the prescriptive envelope U values that are put into that code, and the builder is overlaying whatever U values they want, whatever specifications they want. The point of this exercise is to say, is the builder's house equal to or better than the reference home? Is the geometry, with the same geometry, if I put different R values and U values, is the U value performance equal to or better than the reference home's performance? And so the UA trade-off pathway is this method of performing conductive energy trade-offs through the building envelope. So it's important to know that it's only dealing with building envelope requirements and the ability to trade off R values and U values. So if I'm a builder and say, you know, hell no, I've never put R49 in my attic, I'm gonna stick with R38 in my attic, that's what I believe should be done, that's the most cost-effective thing to be done, that's perfectly fine, but they can't use the prescriptive pathway in the code. They have to move at the minimum to the UA trade-off pathway, or potentially to the other performance pathways in the code, in order to demonstrate that that trade-off actually works and is compliant with the code. So you're trading off R values and U values in that thermal envelope when you're using the U value trade-off. And that's the only thing you're trading off. And remember, you have to do those mandatory items in the code as well. The UA calculation shall include the thermal envelope, bridging effects, and framing material effects. And that's why it's using the U value table there, because it's looking at total assembly R value and U value. Now, there are a number of different softwares that can do this calculation. ResCheck is the most popular one, and sometimes this pathway is called the ResCheck pathway, but the reality is that ResCheck is a software. It is not a pathway through the code. The ResCheck report looks like this, and I'll blow up the compliance part here. It says that the this house is 3.2% better than the code because the maximum U value for the reference home is 375, and the builder's house or the rated house is 363. So the builder's house is less than or equal to the area weighted U value of the builder's house. In fact, it's better than the builder's house. There are other reports from different softwares. This is a report from the Ecotrope software that demonstrates compliance of the projected home. This is a report that you would turn in for your building permit here. So the reference home is 511. The as designed house is 495. So the area weighted U value is less than or equal to, therefore it passes code and it meets the requirements there. Okay, so let's move on to the simulate performance path. We're running out of time here, so I'm gonna have to move pretty quickly here. So this section does very similar things as the UA trade-off pathway, but it only looks at heating, cooling, and service hot water heating. And it gives you the ability to not only trade off R values and U values, but you can trade off house tightness and duct leakage and other things that are moving with air. The energy that is moving with air, you're also able to trade off here. So that's conduction is what's being traded off with R values and U values. Convection is what's being traded off with energy that's moving with air. And we can also look at radiant energy trade-offs. So what you're seeing here is a kind of a progression in flexibility. It turns out, I'll give you the short notice here, is that the simulate performance path is the most flexible path for builders who are trying to figure out the most cost-effective way to build their house and potentially stay with assemblies and components that they are familiar with here. It is the most building science-based pathway as well, because it's the most holistic pathway that's looking at holistic trade-offs here. In the same way that the UA trade-off pathway is doing in the softwares, we have two homes that are built inside the software that are geometric twins of each other. The envelope features that the builder wants to do are compared to those of the reference home, and the builder's house has to be less than or equal to the reference home house. However, instead of using area weighted U values, it's using annual energy cost as the compliance metrics here. So when we get a report like this, we're looking at heating, cooling, and water heating energy use. And we're looking at the energy costs for the reference home. In this case, $1,086 versus $1,034. The builder's house as designed is less than the reference home for code. Therefore, it's passing code compliance, and in this case, it's passing by 4.8%. This is the type of report that you would turn in for your permitting of the house, and you have to turn in another report that's confirmed at the end of the process in order to get your certificate of occupancy. Now, because this is often done by energy raters might also give you a HERS certificate or a HERS energy rating index. You just have to be very clear here that an energy rating index is not a code compliance certificate unless this jurisdiction has specifically said that a HERS or a ResNet HERS energy rating index is what they're looking for code compliance there. Submittal documents, again, you need to submit some documents for code compliance for your building permit, which is this document that's listed out as a projected document. We're going to go through this fast because we're running out of time. And then a confirmed document at the end as well to get your certificate of occupancy. Both documents need to be signed. Okay, our last pathway in the code is the energy rating index pathway. This pathway is complex, and hopefully I'm not going to go through it too fast. The big thing to understand is that energy rating index is now a defined term in the code because HERS is a proprietary term. So they put energy rating index into the code. They created a ANSI standard that defines how you create an energy rating index, and that makes it this generic term like Kleenex or Xerox or Coke that describes what an index is. An energy rating index is a specific defined term now in the code. An index scale established by ResNet is what the HERS index is. It's like a golf score, so the lower the score, the better. It's like a miles per gallon rating for homes so that you can easily determine what the efficiency of that house is. Lower is better again. The HERS reference home is based off of 100, which is equal to the 2006 IECC, so that reference point again that we talked about earlier. A HERS index of 0 is that zero energy home, and a HERS index of 130 is determined to be the average score of an existing home out there in our communities here. We have to remember that a HERS energy rating index is not a code compliant index score for this pathway. The pathway is utilizing the same standards that create the HERS index, but the ANSI standard 301 that creates the energy rating index score for code has been changed a little bit. So the scores are not equal to each other here. So section R406 is the section that deals with the energy rating index score. Again, it's leveraging the HERS index pathway on how to create that, that score, but it is different than the HERS index score. If you have an older code book, you need to look at this section of the code in particular, but all sections of the code, and potentially pull the errata that's been developed for the code, because this section in particular was printed wrong in the first versions of the code book. In the 2015 IECC, it basically said that the mandatory requirements were not required for this pathway, and that is not true. What is true is that the mandatory requirements are required for every compliance pathway in the code. And you have to do all those mandatory requirements plus demonstrate compliance using one of the 4 pathways in the code. The mandatory sections of the code deal with things like ceiling insulation, insulation certificates, air leakage requirements, duct leakage requirements, installation of air barrier and insulation details. Those things impact the performance paths of the code pretty substantially here. Now, section R401 in the 2015 version of the Energy Rating Index didn't reference the ResNet Mortgage Industry National Standards directly, but it used those standards to develop the Energy Rating Index score. It didn't reference the standards directly because it is a proprietary standard and HERS is a proprietary name. So they changed the name to Energy Rating Index to make it non-proprietary, but they leveraged the ResNet standards for the development of that Energy Rating Index score. Now, by the time the 2018 IECC was developed, this non-proprietary standard, ANSI standard, was created that describes how to develop an energy rating index score. It happens to be the same standard that ResNet uses to develop the HERS index score, but the ERI score, we'll see here, has been, this standard has been amended and when it was adopted into the 2018 and 15 IECC. So the scores aren't the same number actually for the code ERI and the HERS ERI, or the ResNet HERS ERI. Okay, so basically the software is doing the same thing that it's doing for the UA path and the simulated performance path by creating a reference home and a home that we're looking at, or a rated home that we're looking at for code compliance. They're geometric twins of each other. The IECC mandatory reference home requirements are overlaid on the reference home. The builder has to deal with a new concept called the mandatory installation backstop, which I'll tell you in a second, and other mandatory requirements in the code here. And so ultimately what we're trying to determine is the builder's house has to be equal to or better than in the code here. So this is, the software is being used to define what the builder's energy rating index is compared to this reference home here. And so in the 2015 IECC, the energy rating index that builders had to meet were defined by this table. And that changed slightly in the 2018 IECC. You can see it went up by about almost 10 points here. So you need to take that into account and understand that the scores are different, not only for different codes, but they're different than the HERS ResNet energy rating index scores as well. If you're using this pathway, you do not gain flexibility. The first reason you don't gain flexibility is that this term backstop was developed. It says that the building thermal envelope shall be greater than or equal to the R values that are defined in the 2015 or 2009 International Energy Conservation Codes. Therefore, again, like the prescriptive path of the code, I have to put in that R49 attic. I can't trade below that. I can add more insulation, but I can't trade below that and add less insulation. In the 2018, the backstop changed slightly to say that if you put solar PV on your house, you have to use the backstop that's created by the 2015 prescriptive R value table. Now that R value table looks like this. These are the 2009 and 2015 requirements and 2018 requirements in different colors here. But you can see in Climate Zone 5 that they didn't change that much here, except for attic insulation and foundation insulation are the main things that changed here. So for example, if I'm building to a 2018 IECC, my attic insulation has to be R49. I can't use this pathway to trade off R values and U values, and therefore it is not the most flexible pathway, and we're not seeing a lot of builders adopt this pathway. Some jurisdictions are adopting the HERS ERI score, not the code ERI score. That would be exemplified in Boulder and Boulder County, for example, have adopted that. The reason they do the backstop is because they want to protect the thermal envelope. So here's an example of a house that was built to the 2006 IECC. If I add PV to this house, I can drop the score from 100 to 55 with a relatively small PV system there. So the idea of the IECC in general with all the pathways is that they really want to protect and have a sound and robust building thermal envelope in order to meet the efficiency requirements of the code and also to meet the core expectations of the consumers that are buying these houses there. And if they didn't put in the backstop here, because the energy rating index system evaluates all the different components in the house, you can see that PV can drop the score pretty dramatically here. Again, the HERS, or the Home Energy Rating Certificate, is an important certificate, but it is not a code compliance certificate here. This is the code compliance certificate for the energy rating index there. And it shows the ERI scores and if they meet or do not meet the code. You need to turn one in, a projected one in for your permitting process to get your building permit, and a confirmed one to get your certificate of occupancy in that house there. Okay, so we just unfortunately don't have time to talk specifically about why the index scores are different from each other in both of the systems. The main reason, as I scroll through here, is because when the code was adopted, the code amended the ventilation section of the ANSI 301 standard for how you develop an energy rating index score. And because of that, these scores changed pretty dramatically. So this is the HERS energy rating index for the same house that was done in the 2015 and the 2018 IECC. You'll see that coincidentally, the HERS index and the 2015 energy rating index are the same, but look at the 2018 energy rating index. Instead of being 60, it's 73. So what we see with that big change that they made with the ventilation requirements in the calculation of the energy rating index for code, that impacts that energy rating index score pretty dramatically and makes it even more difficult to achieve the mandated index score that the code is requiring, which in the 2018 would be a 61. So I've got to figure out how to get from the 73 to a 61 to be compliant, and I'm not allowed to trade off R values and U values to do that here. So again, it's a pretty, it's a pathway that could be flexible, but has not been adopted in a flexible method. So most builders are continuing to use the simulated performance path if they're looking for flexibility in the code. Which ultimately means that we need better education out there. And if we get better education out there about the differences between these codes, potentially we'll get more use of the energy rating index out there as well. What we do know is that this section allows verification by an approved agency, but what that really means is that generation of the code energy rating index should be done by a third party, most likely a HERS rater will be doing that. You have to be cognizant that if you're a jurisdiction and using this pathway of the code, that HERS raters don't necessarily understand compliance with the other mandatory requirements of the code. The generation of an index score is very different than demonstrating compliance for code. So you want to make sure that you're on the same page. Going back to that talk of potentially creating a scope of work document that clearly defines what you want that third party to be doing in your jurisdiction. Compliance reports, again, are needed for all the pathways in the code. You have to now provide compliance reports for duct leakage and air leakage. You have to, in the prescriptive path, there's no true compliance report that's driven. It's primarily inspection driven, but the UA trade-off path, you have to provide the area weighted compliance report, the simulated performance path, the cost compliance reports, and the ERI path, the ERI reports that I showed you there. Inspections, again, for the prescriptive and UA trade-off paths, this generally happens through the code official, but possibly you'll see more and more third parties out there demonstrating compliance with these pathways of the code. For the simulated performance path, a third party has to be involved with this because the only way to demonstrate compliance and generate these reports is to do an inspection process as well. And then the ERI pathway is kind of the same way. You would use a third party to demonstrate compliance. Okay, so our last chapters are chapter 5, which is the existing home section and it's dealing with alterations, repairs in the code. It's a difficult chapter to understand. It's being enforced quite differently in different jurisdictions. So if you're doing anything with existing homes, make sure you spend some time with this chapter and understand what your jurisdiction, how your jurisdiction basically is interpreting the code. And then the last chapter is chapter 6, which is really a reference chapter in the code. So to conclude, we see that the intent of the IECC is to ensure that we have durability, health, safety, and flexibility in our pathways. If you're not finding the flexibility in the prescriptive path, definitely start looking at either the UA trade-off path and the simulated performance path to get better flexibility to figure out the most cost-effective way to build a house in your jurisdiction. there. We're not seeing great uptick in use of the ERI pathway, largely because as a byproduct of the simulated performance path, it's very easy to get an energy rating index for marketing or other purposes that the builders primarily want that index for. Now, I like to talk about the 4 pathways of the code, through the code. That's the UA trade-off pathway. Well, there's actually 5 if we do it this way. There's the prescriptive R-value pathway, there's the UA trade-off pathway, the simulated performance pathway, and I'm sorry, the energy rating index pathway. That is still 4. Simulated performance path offers the most flexibility there. And again, you need to create that working relationship with third parties, inspection agencies, if you're going to use those agencies in your jurisdiction or with your particular house there. So thanks so much again for our sponsors of this webinar series. I appreciate it. I look forward to seeing you again next week. I'm more than happy to stay on and answer questions, or you're more than willing and able to email me or give me a call, and I can answer your questions directly there. So take care until next week. If you have a question, please enter it into the question box.